All right, so we got the 6.6 part 2 homework. I actually forgot all about this assignment until this morning. I thought I had it ready, but I didn't. I'm more worried about y'all's tests that you have this week. So it looks like I have number 3 highlighted here. And the property that we get to use here is a pretty simple property. It says if I have a logarithm of some base, and there's something in it we'll call x, equal to a logarithm of the same base, notice these bases are the same, and there's some y in here, x is y. So I have that situation. I have a logarithm on one side, I have a logarithm on the other. So I know that x squared minus 4x must be 5. Now this is what we call a quadratic. Quadratics get set equal to 0. And then you get your old favorite lesson. It's called factoring. Factors of 5 that will get you to 4 are going to be a 5 and a 1. You're going to have to take away 5 and add 1 to add to negative 4. I still am equal to 0. I get to use the ZPP, zero product property. X minus 5 is 0, so x is 5. Or, and that's one answer, x plus 1 is 0, so x is negative 1. Now, the prereq skill for this was domain or a logarithm with something in it. Whatever's in it has to be bigger than 0. So I'm going to make sure these work, all right? I'm going to talk about this log. This is going to be the issue right here. Log base 2, if I let x be negative 1, I think I'm okay. I end up with log base 2 of 1 plus 4, log base 2 of 5, and 5 is bigger than 0. So this one is definitely a real answer, for sure. 100% real. Now, what happens if I plug in the 5? Well, it's going to work out okay on this one, too. I'd have a 5 squared minus 4 times 5. That's 25 minus 20. I end up with log base 2 of 5. So they're both real. There was no extraneous. It does say look for extraneous. It says look for it. You're supposed to look for it. Solve the logarithm equation by condensing the logarithms and then exponentiating. And the first one I have highlighted here is number 6. And we have to make it look like our property. Well, actually, we don't make it look like our property. We condense the logarithms. Now, I know that addition is condensed through multiplication. This becomes a log base 4, and inside it is a negative x times x plus 10. Because, again, we condense positive logs through multiplication. And that's just what we do, specifically in the numerator. I'm going to exponentiate now. I have a base of 4. I have an argument that's going to be negative x squared minus 10x, because I'm thinking about the distributive property. And I have an exponent of 2. So negative, the base is 4. Its exponent is 2. And that equals negative x squared minus 10x. And I'm going to shift everything left. X squared plus 10x, and this becomes plus 16. Now equal to 0 on the right-hand side. And once again, I'm going to factor. Factors of 16 that add to 10 are going to be 8 and 2. Still equal to 0. So by the zero product property, if I can write, x is negative 8, or x is negative 2. Now these both work. If I negate a negative 8, I get a positive 8. Negative 8 and 10 makes 2. If I negate a negative 2, I get 2. Negative 2 plus 10 is 8. They're both real. Notice I've checked. They're both real answers. If you're muting me, you have no idea what I just did. All right, moving on to 8. Same technique here, condense. And again, I'm going to have a singular log base 5, and she will contain the product of x plus 4 and x plus 1, and she'll equal 2. My base is going to be 5. My argument is going to be what happens when I FOIL this out, which would be x squared plus 5x plus 4, and my exponent is 2. So 5 squared must equal x squared plus 5x plus 4. This makes 25, I believe. Yeah, it does. X squared plus 5x minus 19 is 0 because I shifted that right because I want my x squared to stay positive. And I know of no factors of 19 that add to 5. So it's QF time. Which goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. B is going to be a positive 5. So negative 5 plus or minus square root 5 squared minus 4 times a, which is 1, times c, which is negative 19, all sitting pretty over twice a 1. And as tired as I am, I'm not going to do that in my head. I have 5 squared minus 4 times 1 times negative 19. So inside my radical is the root of 101, which does not simplify. So I get x equals negative 5 plus or minus the root of 101, both pieces over 2. So now I am going to check for the extraneous and the real. I am. I'm pretty sure the negative 5 minus root 101 doesn't work. Negative 5 over 2 minus root 101 over 2. Notice how I'm typing. It's going to be that decimal, negative 7.52. Now, if I put a negative 7.52 here, think about that. Log base 5 of negative 7.52 plus 4 is log base 5 of negative 3.52. And that will make the log puke. And it won't work here either. So, here's what I've learned. X equals negative 5 minus root 101, both over 2, is extraneous. Now, I'm going to get a positive number when I put these together. I know you may not believe me because your number sense is just atrocious. But if I do negative 5 halves plus, and I'll just push buttons so you can see it. If I do the plus, it's a positive number. Logarithms like positive numbers. And I'm going to have positive things in here. So the other one, the x equals the negative 5 halves plus root 1 over 1 over 2 is real. They both matter. And there is number 8. Cool, done with that page. Moving forward in my life. Be the second time this question's been in here. Suppose an investment pays $25,000 on a yearly basis. If you invest $10,000 for 1 month, what will it be worth? What was the effective monthly rate? So we're going to use the formula here, yearly basis. The amount of time passes the principal times 1 plus r to the t. This is 0.25 as a decimal. There's your principal. 1 month is 1/12 of a year. So after 1/12 of a year, I would have 10,000. 1 plus 0.25, 1.25 to the 1/12th power. And there's other ways of doing this problem. There are 10, 1, 2, 3, 1.25 roof-topped to the 1/12th. I need to hurry up. There's a bell. $10,187.69. Now, you grew by $187.69. If you want to figure out your effective interest rate, just take your 187.69 and divide it by what you invested, 10,000. That ought to do it. Minus 10. Divided by 10,000. And there she is. 0.0188. And if you want it as a percentage, you move that decimal twice, 1.88% per month. Now, if I take the full decimal, if I add 1, and I raise it to the 12th power, I should get close to 1.25. Maybe you catch on what's going there, maybe you don't. I don't know. I know a lot of people don't understand percentages. They don't understand interest, just a lot of things in general we don't understand. That's how I've always checked myself. You know, I figured most of this out around 6th grade. That's how I check myself. All right. Looks like we got 3, 4 left to go. All right, solve the exponential equations. I noticed that these two, there is no common base. So I'm going to ln both sides. I have the ln of 10 to 3x minus 8 equal to ln of 2 to the 5 minus x. This guy goes out front. It's two things, remember to wrap. Now we're going to do what's called the distributive property. 3x ln 10 minus 8 ln 10 equals 5 ln 2 minus x ln 2. Now I'm going to get everything with an x on one side and everything else on the other. So 3x ln 10 plus x ln 2 equals 5 ln 2 moves over plus 8 ln 10. I'm going to factor x times 3 ln 10 plus ln 2 equals 5 ln 2 plus 8 ln 10. And the opposite of multiplication is division. So x is 5 natural logs of 2 plus 8 natural logs of 10. Sitting pretty over 3 natural logs of 10 plus the ln of 2. That needs parentheses. If you like what you see, if you like this, take pre-calc next year. Plain and simple. If you understand that, take pre-calc. If you don't, don't. 18 does have a common base. I noticed that. We have a common base. 6. 36 is 6 squared. You got the exponential space 5x plus 2. 1/6 is 6 to the negative first. The exponential space is 11 minus x. Drop the bases. 2 times 5x plus 2 must be 10x plus 4. Negative 1 times 1 is negative 1. Negative 1 times negative x is plus x. X is on one side, numbers on the other. 10x minus x is 9x, Negative 1 minus 4 is negative 5, and x is negative 5/9. I've got 4 minutes till kids get in my room, so that's why I'm going fast. Still kind of slow. 2 more, and both these have common bases. 25 is 5 squared. Still got 10x plus 8 in the exponential space. 1/25 would be 1 over 5 cubed, so it's 5 to the negative third power. And you have 4 minus 2x in the exponential space. The distributive property kicks in. 20x plus 16 must equal negative 12 plus 6x. X is on one side, numbers on the other. 20 minus 6 is 14. Negative 12 minus 16 is negative 28, so x must be negative 2. Number 20. I'm going to leave this 3 alone because I know that 81 is 3 to the 4th power. And then I have, stuffing away, 12 minus 3x in the exponential space. Throw away the bases. 3x minus 7 must equal 48 minus 12x. Let's shift our x's over here. 3 plus 12 is 15. 48 plus 7 is 55. Divide out my 15. 55 and 15 are both divisible by 5. 11 thirds. Done. Oh, there's one more problem. And it's a word problem. Determine all zeros, real and imaginary, of this function. It says, hey, you, look at the graph. So since it says look at the graph, obviously I'm typing stuff into my graph. Makes sense to me. I hope it makes sense to you. Almost forgot my x. And I'm going to hit zoom, and I'm going to hit 6. And I forgot to do something. See, I want the zeros. So I need to put a 0 into y2. Oh, this is the same one that's on your log test twin. Anyways, there we go. I can read this one. This is where x is negative 2. This is probably a quarter, a third, 1 and 2. Second trace 5. Get close. Enter, enter, enter. It's 1/3. So from the graph, x equals negative 2. Or x equals 0.333, which is 1 over 3, which is what we're going to use. Then we're going to do some synthetic division. Coefficients are 3, 5, 25, 45, negative 18. And I'm going to start with a negative 2. I'm going to drop the 3. Negative 2 times 3 is negative 6. 5 and negative 6 makes negative 1. Negative 2 times negative 1 is 2. 25 and 2 makes 27. Negative 2 times 27 is negative 54. 45 plus a negative 54 is negative 9. Negative 2 times negative 9 is 18. 0. Because I got a 0, I reuse the reduced quotient. I'm going to put a third out front now. There's a third. There's a third there. Third of 3 is 1. Negative 1 and 1 makes 0. Third of 0 is 0. 27 and 0 makes 27. Third of 27 is 9, 0. What I've done is I have successfully synthetically divided everything out and reduced this from x to the 4th to x squared. I have a remainder, I have a constant, I have an x, and I have an x squared. I have 3x squared plus 27. There are 2 more zeros here, so I set it equal to 0. And then I have basically 3 steps, 4 if you include radical simplification. I subtract 27. I divide out my 3. I take the square root, so I'm plus or minus. And I know that this is imaginary. And I know that the root of 9 is 3. So these are my zeros. X equals -2, 1/3, 3i, and its conjugate, -3i. And that is your homework. I did not do any ACT. You're welcome.